populations may be too small to be viable. So precisely, the populations are found very far apart, there's very little to no dispersal between them, and each of those individual subpopulations has an increased risk of extinction because it is so small that it may not be viable. So a lot of people, it's a common mistake when you're doing a red list assessment to think just because a species is found in a habitat that is fragmented, that it qualifies for severe fragmentation. And it's important to keep in mind this definition and ask yourself whether the actual extinction, whether the viability of the population is affected by that habitat fragmentation. So here, for example, if you have taxa with highly mobile adult stages, or that produce a large number of small very mobile diaspores or young, they can disperse more easily. So they're not vulnerable by this fragmentation. I mean, here we have different sized populations. They are in fact fragmented, but if any of those populations were to go extinct for whatever reason, they could be recolonized by the neighboring populations. And obviously, the opposite is then, therefore, the definition of severe fragmentation. If you have taxa that produce very small numbers of diaspores, or none, or only large ones, or the mature individuals are not able to distribute very easily over large distances, then any one of those populations might go extinct. And if it did, there would be no recolonization and there'd be no way to recover that subpopulation. So that would be a severely fragmented species. I'm going to go over these as well because these are not intuitive. Extent of occurrence and area of occupancy are basically two different ways to look at the species range or distribution. A lot of people, when they're doing a red list assessment for the first time, ask us how the species range fits in. You know, they might have data about the size of the species distribution in general. And we don't actually consider that general definition of range. We look at these two specific definitions that basically, there are two different ways to look at how a species is distributed over space. So in the first, the extent of occurrence, it's the area within the shortest continuous imaginary boundary drawn around all of the known, inferred, or projected sites that are presently occupied by the taxon. So you wouldn't include historical point localities, for example. You would be looking at the species' current distribution and all of the areas where you know the species is found or you believe the species is found. You would draw what we call a minimum convex polygon. So none of these angles are greater than 180. And within that polygon, that is the extent of occurrence. So the species range, or one way to calculate the range might be to sum up the area of all of these individual circles. And just to highlight that that's not what we're calculating here. The reason that we measure extent of occurrence, it's actually less a measure of the species' range size, and it's more a measure of the spatial spread of the threat to that species. So if you have a species that's found over a very, very large area, any one threatening event is less likely to impact the entire population of that species, because that one threatening event will generally cover only a certain, smaller geographic area. So if our threatening event was logging, for example, logging might wipe out this entire population and perhaps this entire subpopulation, but it's not going to affect one logging event or one tract in which a logging company would operate wouldn't necessarily affect this subpopulation. If you have a species that's found in a much smaller space, there might be lots of little subpopulations, but it's found in a smaller space. Any one threatening event is going to impact a larger proportion of that species population. So extent of occurrence, a lot of people think of this as the species range, but it's actually not really a measure of the species range. It's a measure of how widespread the species is, and therefore how likely it is that any one threatening event is going to increase that species extinction risk by affecting a large proportion of the population. We also measure the area of occupancy, which is a much closer estimate of the species' actual range. There's a very specific way that we measure this, and that's by laying a 2 by 2 kilometer grid over a species, basically over the species distribution map, and then counting the number of grid cells that are occupied by the species range. The reason that we use a 2 by 2 kilometer grid is because the area calculated using a grid of that size translates well to the thresholds in the criteria. So some people may have data at higher resolution or lower resolution and would want to use a 10 by 10 kilometer grid or a 1 by 1 kilometer grid. And we would really recommend that people use a 2 by 2 kilometer grid because that's going to give you the most accurate number that translates well with the thresholds and the categories. And there are several different ways to measure area of occupancy for riverine species, for example, or species that are found in basins. But this is the one we recommend. There are a couple of others outlined in the user guidelines. And this just shows the...
Sorry, can you go back to the last slide? So there's a couple of grids there which have got bits of range in them which don't have occupancy. Why is that?
It's really so talking about things like this.
Yes.
Yeah. It's really because, I mean, it's a rough estimate. It's not a precise estimate, a precise measure, and it's really to account for the fact that yes, only a little bit occurs in here, but that could easily occur in this area here. It's only really meant to be a very general estimate to link in with the criteria thresholds, really. Clearly there's going to be areas that this counted for the species does not occur because it's unsuitable habitat still in there, because we're looking at a 2 by 2 square kilometre, 2 by 2 kilometre grid size, which is relatively big if you're looking at something that's quite habitat specific. So it's just to kind of account for that.
Basically, if you centered the grid cell differently, then you would get more or fewer grid cells counted. And the red list criteria are very broad, so like Caroline said, it is a very rough estimate. And for the most part, species will fall into a specific category because the thresholds are relatively broad. So shifting the grid a little bit, for some species it might make a difference, but for the majority of species, they'll still fall into the same category.
Can I just add to that as well? We have often had questions about things like what do you do about species that occur in freshwater and only occur in very narrow streams, so a very linear habitat. When we're recommending overlaying a 2 by 2 kilometre grid, clearly you're going to include lots of land where if it's a fish, it's not going to occur on the land unless it occurs in flood zones or something. And people wouldn't accept that this actually applies to a rough estimate that leads to meeting a particular criteria threshold. So we tested it out to try and demonstrate that it doesn't actually modify the final category by much at all in most cases, or even at all in most cases. So we actually looked at overlaying grids and compared with measuring the length and average width of the linear habitat for assessments, and in over 90% of the cases, over 95% of the cases I think it was, there was no change in the category, depending on whether you used this or the other method. But in a small percentage of cases, there was a difference between the categories. It might push something into critically endangered if you use the more refined method, or endangered if you use this grid overlay. And a slight difference of opinion between the red list unit and the standards group on this. So within the red list unit, we would say, if you have the data and the species is very well surveyed, and you know that it occurs there, so you need to have very good supporting evidence for it, then we would say go with the higher category, because you've got evidence to say, yes, this is actually highly restricted. However, if it's something that you think occurs there, you don't know if it occurs upstream, downstream, wherever, then we would recommend go for the grid overlay. The standards group would say always use the grid overlay. That we, if we got an assessment and we kind of use a bit more logic on that, and if there's enough evidence, then we would say yes, okay, it qualifies for the higher category, but there would need to be lots of evidence for it.
So in a small number of cases, was there any sort of commonality between those?
All of the cases were freshwater fish anyway, so the commonality was they occurred in very narrow streams, and they had lots of data available. But the vast majority of cases it really didn't matter, because you will see later on that when we look at the thresholds, we're looking at a very broad band of figures. So you're trying to fit something into a range of figures that falls between say 10 square kilometres and 100 square kilometres. So in most cases you're going to be looking at something that falls well in the middle rather than right on the edge. It's those edge cases are the ones that you have to decide.
Basically, we would recommend, you do get cases where you are right on the edge, or where, depending on how you interpret the data, the species could fall into one or another category. And at that point, you just need to use common sense. And we would recommend that people be precautionary, but realistic. And just explain in the information that you write how you made the decision.
Can I also point out that it's 15 minutes into the coffee break?
So, well, I think we can get through the next 2 slides. There's only 2 more slides. So this just illustrates that. The species, these might be point locality data for where you've collected the species. The blue hatched sort of polygons might be what you would generally consider to be the species range, might be how you would calculate the range area. The extent of occurrence would actually be everything within this orangey polygon. And to calculate the area of occupancy, you would actually lay a grid over if possible and calculate all of the points. There are different ways that you can do this. And you could, if you're very confident in the data, actually calculate the squares that are occupied. Sometimes you only know a species is found from a forest. You don't actually know, for example, where it's found in that forest. So you may just end up calculating all of the squares. You might calculate all of the squares that cover this kind of reddish area, which is the forest. Or you might actually calculate the squares where the points are, depending on how good your data is. There's just one more term, so the coffee break's on until 11. We'll end up having 15 minutes, so we'll go through this one quickly. Does anyone know what a location, what might you think a location would be? This seems like a very obvious question. It's not.
That's why everyone's hesitant.
Let's say an address where they are.
So locality, like where the species was collected. That's what everyone thinks a location is. It's logical, location, locality, it makes sense. But actually, location, that's not what location means. And this is the most easily confused term in the red list categories and criteria. So, the definition of a location is a geographically or ecologically distinct area in which a single threatening event can rapidly affect all of the individuals of the taxon. So it's actually not defined by where the species is collected at all, and it's not defined necessarily by where the species is found. The key for defining the number of locations is the impact, the geographic impact of the most plausible threat or the most serious threat. And lots of people, when they're submitting the red list assessments, they'll just say the species is found from 3 lakes in northeastern Cameroon. It's found in 3 locations. And that sends off red flags to us because we don't know whether they calculated 3 locations because it's found in 3 lakes, or whether they calculated 3 locations because the most serious threat to that species might be fishing. And fishing in one lake won't affect the fish in another lake. So you really do have 3 separate locations because each of those lakes is impacted by separate fishing events. So, yeah. Oops. So just to give an example, if we have a riverine species here, well, a freshwater species is found in a river and a lake, an invasive species is the most serious threat to the species we're assessing. If we say that once you introduce invasive species to this river, they're going to easily and quickly colonize the entire river. But they can't crawl over land to get to this lake. You're going to end up with 2 locations. And that's because once invasive species have been introduced to this river, all of the individuals, all of these little black dots, are impacted by that one threatening event. And you would have to introduce the invasive species separately to the lake.
So then my question to understand is, so the location is relative to the single most important threat, is that? Because you could have threats acting in different ways, so that it might be, drought might be one, well, if you introduce land change or something, might be a threat that comes to all the locations, but then it does, be more than one location.
So generally, it really depends on the species. Generally, you look at the most serious or the most plausible threat, but if there are lots of different threats acting over different parts of the species distribution, then you can measure the number of locations based on the threats that are acting in those areas. There's a lot more information in the user guidelines about defining location, because this, well, I'll go to the next example and then we'll see another thing that comes up when defining number of locations. Let's say, for example, that pollution is the most serious plausible threat. And once you introduce pollution, if they build a factory here and the pollution starts going downstream, then it will affect all of the individuals downstream. Let's say it's a really concentrated chemical that's going to stay highly present in the water as it goes downstream. How many locations would you think there would be in this example?
5.
How many?
5.
5. 4. 3? Anybody for 3? 4. Okay. Well, we cheated a little bit and we say there's 4 to 5. So this is one location. You wouldn't necessarily count above that point because there are no individuals found higher up in the stream. And then you would have to have additional pollution events in the lake and in each of the tributaries to the river. And that would be 4 locations. But the truth is, depending on where you build your factory, you could have more locations. So if pollution were happening, or depending on how strong the pollution is, if it's local use of the river system for washing clothes and bathing, then that might only impact the species that are found here, and this might be a separate location. Or it's really going to depend. It's hard to give good examples of locations because it really depends on the species that you're assessing and the threats that you're considering. It's easy to have long, heated debates about location because there is a lot of interpretation that comes in. And just to give a final example before we break, this is directly related to your question earlier, Harriet. If the most serious threat doesn't affect the entire distribution, you can use other threats to count locations in areas that aren't affected by that threat. So if you had pollution affecting this part of the river system and in this part of the river system, but there was a dam that was going to be built in another part of the river system and fishing was a heavy threat in this part of the river, you could have 5 locations. And again, this is variable, so you would have 1 location here, 1 location here. Fishing would be another location, and then the dam would impact everything upstream of the dam, so that would be another location. Depending on the species you're assessing, This could potentially be another location, because downstream of the dam, you wouldn't expect there to be as much of an impact. And then this, of course, there's nothing happening here, so that could be counted as another location. If there are no plausible threats, then you don't consider the locations at all. And we see lots of assessments for species that say, there are no threats to this species, it's found in 3 locations. So in that case, it's clearly found in 3 localities. If there are no threats to the species, you don't even need to start thinking about what the number of locations might be. So we can talk about that a lot more in the case studies. It's hard to think about locations in an abstract way. I suggest we break for coffee. I'm just going to leave the last, this is the last definition. It's pretty straightforward, so you can just read that, as you come in or before you go out. And if you have any questions, then we'll take them after the coffee break, or you can ask us. Can we be back at 5 after 10? Oh, sorry, 5 after 11?